All right, so another way that we use molality or molarity and typical problems where they give you the percent and we calculate it based on the percent concentration. So make sure you pay attention to this problem. So we have an aqueous solution of hydrochloric acid contains 23% HCl by mass and a density of 1.28 grams per milliliter. It asks us for three things, A, B, and C. The mole fraction of HCl in the solution, the molality of the solution, and the molarity of the solution. So, all right, got interrupted. So what I'm going to do is, like a lot of these, I am going to assume I have 1 liter of solution. All right, if I assume 1 liter, that can help me with molarity down the line. What I need to do now is I take the 1 liter and I'm going to use the density to find the mass of the total solution. So I take 1 liter and it's really 1,000 milliliters and I multiply it by the density of 1 point, why did I do that? 1.28 grams per milliliter, and I get 1280 grams. All right, then I can use this just idea right here. 23% of it will be the HCl, and 77% of it will be the water. So if I multiply this number, I'll do it kind of up here, by 0.23, because that's 23% in math is 0.23. Then down here, 0.77, that will tell me the grams of each thing. So I've already done this and I get 294.4 right here. All right, let me thin this up. Okay, and then you could subtract and get that, or you can just multiply it. It doesn't really matter. And I get 985.6. All right, these are the grams of my solute. This is the grams of my solvent. That will become really handy pretty soon. Okay, so now both of these things need to be converted to moles. So this is HCl. So I'm going to divide it by 36.5. And I already have that as well. I get 8.07 moles HCl. I wish I would have written this out a different way. Anyway, I divide this one by 18 because that's the molar mass of water. And I ended up getting 54.8. Oh my, Tom. And that's moles of water. Okay, now I'm going to erase this, so make sure you're with me, but I'll do the rest of the mole fraction down here. I need the mole fraction of HCl, so I take the number of moles of HCl, which is 8.07 moles of HCl, and I divide that by the total moles, which is, once again, 8.07 moles HCl, plus the moles of water, which is 54.8 moles H2O, and I divide that and I get 0.128 as my mole fraction of HCl. If I needed it for water, I would just subtract this number from 1. So it would be what, 0.882, something like that. No, 872. It doesn't matter. And I would have that. Okay, so the step, once again, assume 1 liter. Use the density to find the mass, and then use the percentages to find out the grams of solute and solvent, and then convert it to moles, and then do the mole ratio, which is moles of A divided by total moles. Okay, now molarity. Oh, molality, I guess, is next. The molality, once we have some of these numbers, there it's quite a bit easier. The molality is moles of HCl per kilogram of solvent. Well, I have all those numbers already over here. The moles of HCl are right here, 8.07. The kilograms of solvent I have right here. Now this was grams, so I need to move it over 1, 2, 3 places, but I have 0.9856. So I already had both those values that I needed. I type that into my calculator and I get 8.19. It's an 8 molal. All right. So once we did this process, they fly really quickly. Part C, find the molarity. So molarity will also go very quick. It is moles per 1 liter of solution. All right, well, way up here, we assumed 1 liter. Okay, we did that up here so that everything else would go pretty quick. We could have chosen any volume we wanted, but we chose 1 liter, so this math would already be done for me. The moles of HCl, I should put that here. The moles of HCl, once again, has already been found. It's 8.07. Then the liters are already found because I assumed it was 1 liter. I started that whole thing. So this is moles. So I have 8.07 moles per liter, which is just literally 8.07 moles per liter. I don't know why my 8s have turned into that ugly look there. So there are our 3 answers. We have, let me highlight them. Our mole fraction, 0.128. That math will lead us pretty quickly into molarity. Our molality ended up to be 8.19. Hideous, but it's there. And our molarity is 8.07. Okay, I hope that sort of clicked. I want you to do another problem while I'm gone still. And it's just like this. I want you to do the same problem, except I'm just going to change the numbers. So let's change, it's 40. Okay, that's fine. This is 40. And then we'll change the density to 1.09. So I should be home or back soon, but you try to find the mole fraction, the molality, and the molarity of the solution based on the same thing that we just saw.